afternoon for you. It's morning for me because it is before school. But it's afternoon or evening for you, so good evening. And it's Monday night. I'm really shooting for this to not be a very long video, but I just wanted to give you your notes so that you could be ready tomorrow to review for a quiz that we're going to have on Wednesday. So today's lesson is lesson 3.3, which is graphing linear functions. All right, so we're trying to get back in the swing of things after our 4-day, extended weekend. So what we're going to do first is we're going to make a chart. And it doesn't matter how many lines it is. You're going to need at least 5 lines down. And on the top, you need to make 3 columns. The middle column is wider. We have an X column, a Y column, and in the middle, I'm going to put the function y equals 2x plus 1 in this case. All right, so here's our function. We're going to try to I'm going to give you the x coordinate sometimes, and I'm going to give you the y coordinate other times, and you're going to use the function to try to give me the other value, all right, what's missing. So go ahead and fill in that chart, and we'll start with number 1, or the first the x value that we have first is 0. We need to find what the y value is. So we're gonna need to do y equals. We're trying to figure out the y. We don't know the y, and we're just gonna plug in 0 for x in the problem. So 2 times 0 plus 1. Okay. All I did was put the 0 in the function. 2 times 0 is 0. I'm just going to write that up here. 0 plus 1, and that equals 1. So the y value when x is 0, using this function, 2x plus 1, the y value is going to be 1. Okay? So next we have, they give us the y coordinate. So we're just going to do the same thing. We're going to plug in y, 3 equals, where it says y equals 2x plus 1. All right? So now we can go over here and we can solve for that. 3 equals 2x plus 1. We're trying to get x by itself. So this is just like a function, just like an equation, sorry. We need to first get this plus 1 off, so we're going to subtract 1 from both sides. You get 2 equals 2x, because this zeroes out, okay? And then we need to divide each side by 2, so we get 1. This cancels out, and then, of course, this also canceled out, and it's 1. So when y is 3, x is 1, okay? If you need to stop at any point, you can. This next one, we're going to just keep filling in our chart. They give us x, so we need to figure out what y is. So y equals, we don't know y equals 2 times 2 plus 1. Just plugged in my x where it is in the function. So 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5. And now we have one more, which is, they give us the y. Negative 1 equals 2x plus 1. So we're going to go over here again. Negative 1 equals 2x plus 1. Do the same thing as last time. Subtract 1 from each side. Okay. And this cancels out, it zeroes out. 1 minus 1 is 1 plus the opposite. So you end up with negative 2 equals 2x. We're going to divide that 2 off the x on both sides. You're left with x over there. And a negative 2 divided by 2 is negative 1. So when y is negative 1, x is also negative 1. So let's look at our chart. We should be able to tell from the previous night's lesson what a linear function is. It gives you a pattern, okay? So let's look at over here. We have plus 1, and then minus 3. This is not a pattern. So this is not linear, okay? And now we could use these values to plot some dots on a graph, because now we have an x and a y. So let's just write out these coordinates. X is 0, y is 1. Okay, check, check. X is 1, y is 3. Check, check. X is 2, y is 5. Check, check. X is negative 1, y is negative 1. Check, check. So we can look at this, and can you, from these ordered pairs here, could you see if it is a function? We just have to look at our x values to see if they repeat. Is it a function? Yes, it is a function. Yes. Okay? So, now you're able to, we've been doing these on our builders a little bit, but it's not been in a table form. And now you could really plot these on a graph. If I gave you some graph paper, you could plot 0, 1, 1, 3, 2, 5, and negative 1, negative 1. Okay? So we have one more thing we want to cover for tonight. And it is, what we need to do first is we're going to review over what is the domain. All right, so domain, if I were to ask you what's the domain in a function, hopefully you would be able to tell me, is it the x or the y? It is our x values. Okay? And what is the range? Those are our y values. Okay? So we have just a little vocabulary here. A point or set of points which can be graphed is called a relation. Okay, so that's a new vocabulary word. It's called a relation. So I'm going to give you some ordered pairs, and you're going to identify the domain and the range of the relation. So here's your ordered pairs. Negative 2 and 4, negative 1 and 1, 0, 0, 1, 1, and 2, 4. These are your ordered pairs. So the relation has to deal with domain and range. It's really just the domain and range together. So we could figure out the domain of these ordered pairs. And they are just the x values, negative 2, negative 1, 0, 1, and 2. And pause it and see if you can go ahead and write down the range. And then come back to me and see if you're right. I'm going to write down the range too. Did you get it right? You know what? Look at this one. Sometimes it doesn't have to be, since we're not talking about our x values here in the range, if they're repeated, you don't have to put them twice if they're the y values, okay? So we already know it's a function because there's no x values repeated, but you could change this in to this if you just wanted to. you don't have to repeat this one and this one. Okay? I'm just letting you know. If they do repeat, you can just, you don't have to put them in there twice. All right? Okay, and last thing tonight is two other new words. When you're looking at a set of points on a graph, we already know how to test if it's a function or not. We can use our vertical line test, but there's two. We also have to have. I'm going to teach you how to tell if they are what's called discrete or continuous. So let's figure out what is discrete. Let's write this down first. Discrete. Discrete data is distinct points that would not, and underline that twice, would not be connected on a graph. Okay, so distinct points are, discrete data is distinct points that are not going to be connected on a graph. So I'm going to give you an example here. Just drawing those little dots. It's when you just have dots on a graph. There's no lines that connect them. Okay, no lines. Continuous is the opposite. Continuous data is an infinite number of points that, oops, there's no E on the end of that are connected on a graph. Okay, so continuous, an example of continuous would be this. We have this. They're all connected with connecting the dots basically. Or this. Okay, there's a line. There's a line that connects all the dots. It's not just dots. This is continuous. This is what's called discrete. And then lastly, I want you to look back at the previous night's video, which I realized was assigned to you on Wednesday night, but it was the last video. These graphs, okay, and I want you to tell me which two, there's two of them, which two are discrete and not, and then you'll be able to figure out which ones are linear. So talking about what we just said, discrete is just the dots, not connected, and continuous is connected by a line. So we could go back and we could say, this is continuous, this is discrete, this is discrete. I connected them myself, but the graph itself was not before. This is continuous, continuous, continuous. All right? So numbers 2 and 3 were discrete and the rest were continuous. Okay, well that's it for tonight. We'll see you tomorrow in class, and we'll talk about when we're going to have that quiz and how that's going to look. All right? Have a good night. See ya.